thank you, Jeremy, for the invitation to be here. This is my first trip to Happy Valley. I have to say, as flying in last night, I felt like I was returning home. I spent my years in school at North Carolina State, so we were the agricultural school of North Carolina. And much like Penn State is the agricultural school, see the farms and the around. And I'm reminded of, I was wooing my wife at the time, and she actually went to University of North Carolina, the uppity school in North Carolina. And during the rivalry weekend of football, she won a t-shirt from the local radio station. How do you break up with a guy from NC State? You send him a John Deere letter. Fortunately, I never got the John Deere letter, so 40 years later, we're still married. I started off again at NC State, a mechanical engineering graduate in 1984. Was excited to be there when our last great national championship occurred. That was fun. I've spent 39 years in manufacturing in the pulp and paper industry, and I've worked in all aspects of manufacturing, from operations, engineering, maintenance, as well as plant management. And I have to say that as a husband of one, the father of 6, and the grandpa to 8, that the title that I've been working hardest for and am most delighted to carry is the title of grandpa. So that's C.A. McDonald, a little bit of introduction there, and now let's talk about RYAM Advanced Materials to give you a little bit of information on that. I've got a short video to share with you.
Forests are vital to humanity and habitat on this planet for the many benefits, services, and products that they provide, including oxygen, clean water, wildlife habitat, carbon sequestration, recreational opportunities, in addition to the thousands of products that are manufactured from trees.
RYAM as a company has been around for almost 100 years. We operate biorefineries in the United States, Canada, and France, and we employ almost 2,500 employees. RYAM is an expert in cellulose chemistry and converting renewable trees into remarkable products.
Innovation is a cornerstone of our culture. This includes creating new processes in our mill, continuously improving those, as well as developing new products with cellulose and our co-product streams. Most people are familiar with cardboard boxes or copy paper, but what we do here at RYAM is much more demanding. We go into specialty filtration, absorbent materials such as baby diapers, but then we also go into dissolving pulp application. So this is looking at cellulose acetate, which goes into LCD screens and cellulose-based plastics, cellulose ethers for pharmaceuticals and time-released. We also go into specialty applications including sausage casings, run-flat tires, that's performed through the viscose process.
RYAM's customers value our products as much for their high quality and performance-enhancing attributes as for their sustainability. RYAM has a long history of customizing its products to meet our customers' ever-changing needs, as well as developing new products to address emerging societal needs. And we do that using trees as our primary raw material, trees that are sustainably sourced from working forests. Working forests are forests that are actively managed to generate revenue from multiple sources, including sustainably produced timber. Therefore, a working forest will remain a forest instead of being converted to other land uses such as agriculture or development.
A new growth forest, younger forests are going to grow faster than older trees. And when they grow faster, they're going to absorb or sequester more carbon out of the atmosphere than an older growth forest. If forests aren't actively managed through appropriate thinning and cutting cycles, then the forest becomes susceptible to fire damage or harmful insects, both of which would release the stored carbon back into the atmosphere. So when we harvest trees, the carbon stored in the cellulose fibers of our pulp and subsequently in our customers' products remain intact for as long as that product is a product.
What BioFuture means to RYAM is leveraging what we have been doing well for nearly 100 years by investing to grow our current high-purity sustainable products and lower our raw material usage and operational impact to the planet, accelerate R&D to identify, create, and commercialize new naturally based bioproducts, and seek opportunities to invest in new companies that have promising technologies.
So that's RYAM Advanced Materials. We are a pulp company, dissolving pulp primarily, And the key aspect of pulp companies is we are one of the most capital-intensive industries in a single plant site, and we get there because it takes literally hundreds of chemical unit operations to transform and to take the molecules that exist in the renewable natural resource of the tree and turn those into economically valuable molecules for the marketplace. And so the challenge of reliability in a system like that, you cannot afford to have redundancy. You can't achieve reliability purely through redundancy because of the numbers of unit operations involved necessary for success. So fundamentally, I'm going to talk to you a little bit about the model that we use. It's a people-based model to deliver reliability within RYAM. Starts with a process. Again, hundreds of chemical unit operations that all have to be controlled and managed to deliver the particular characteristics that we're looking for. It takes groups of mechanical engineers to design then and to operate and to manage those pieces of equipment so that the product and the consistency are there within the process. But at its root, we call this the three-legged stool. We've got equipment, process. The most important element is people. And it's how do people work together to deliver reliability within the environment of a dissolving pulp mill. So what we've done, if we have people, one of the most important things that people need is a vision. And so we've shared a vision for our folks of running our equipment from scheduled outage to scheduled outage at the peak reliable rate. Now we're located in Fernandina, about 75 miles north of Daytona Beach. Nobody wins the Daytona 500 by running continuously for 500 miles. You have to run the equipment, you have to stay on the track, you have to compete when you can do that, and then you simply have to stop at pits. And the people who win make the best decisions when they have those opportunities to take their equipment into the pits. No one wins the Daytona 500 race by turning the fastest lap. It is the combination of continued operations over a sustained period of time that leads to success. And that same thing is true in a dissolving pulp mill, and that's the vision that we share with our people. The purpose of the vision is to create an internal standard in every operator and mechanic when they ask themselves, how do I fix this piece of equipment? Am I simply going to use baling wire and duct tape and get it to tomorrow? Or do I want it into perfection where it never breaks down again? The answer is neither. It's somewhere in between, and we want them to know that when they go about that. So we give our people a vision of a reliability. The second thing we do is we create a model, a visual model, an operating system to work within a team. Success at Penn State and the football program here has done the same thing. Any successful team has a model within which people operate that begins to define the things they do, the way they relate to each other, how they make decisions, and what priorities are. So let me break the RYAM reliability model down into its elements for you and kind of share some of the ways we think about reliability from a model perspective. First, we people are created for relationships. We work with each other, we accomplish things through interchange of ideas and information and priorities. So what we do within our plants is we create reliability teams whose purpose and process is designed to help them know the condition of their equipment. You can't run from scheduled outage to scheduled outage if you do not know the condition of your equipment. So that's point number one. The other thing is the people have specific roles. It's a cross-functional team of maintenance, operations, and engineering. Each one of those people brings special skills, special insights, special experiences to the role of keeping their area of the plant successful. Last and perhaps first, we actually break our plants down into specific areas. We call those fence lines. And we divide our plant up that way so that we know a group of people is personally responsible and accountable for a particular part of the plant. So the plant is broken down into particular fence lines that each have to deliver what they and only they can deliver to the organization. And then the individual chairs in that team deliver the specific responsibilities that they and only they can deliver to the team. We also then have a team, we've got standard work within the team, so we offer a template of how they interchange and how they operate as a team, what they follow. It's a weekly meeting, and they have specific responsibilities. We start with an agenda where everyone knows exactly what they're supposed to bring, and the first thing we do when the team comes together is we take attendance. Why is attendance important? Attendance is just like blood pressure in a human or vibration in a piece of equipment. It's a sign of health. If the people stop showing up for meetings, you don't necessarily know what the root cause is, but you know that that's a sign that that is not a healthy team and things need to be done to help that team. So we start by taking attendance. And when management reviews the data over the course of the quarter, we make sure we understand we have healthy teams functioning. Then the team takes a look at how has their fence line delivered to the rest of the plant what they are supposed to deliver for the previous 7 days and for the previous month. And so they take a look at how are we doing at doing what we're supposed to for the rest of the plant. After taking a look at did we deliver as a team, we ask ourselves the question of how did each one of us do on delivering the task, the standard work that's necessary for me to know the condition of our equipment. Each one of those chairs has specific responsibilities and they bring to that data. We measure to make sure that people have completed PMs, people have completed operator inspections, et cetera. And we do that. We have specialized inspections, we have prioritizations of watch lists as well, and then we take a monthly pull off the road to take a look at, okay, what's our big picture data? You can get myopically focused in a weekly meeting, and so every once in a while we pull off the road and take a look at our big picture data. I'll have some examples of that. But that's a template that the team follows on a weekly basis. So each of those members has specific roles and specific standard work. If I'm not there, someone has to be sitting in my chair. They vote my shares. They bring the information that I am accountable to bringing to the meeting, and they participate in the decisions that the team has to make. One of the key places that the reason that we have had success with KCF's vibration data is because basically we've placed the ownership of that data in the hands of the vibration technician. We already had these people who were part of the team who were responsible for bringing vibration data to their coworkers and their team members. And so now they have a better, new and improved tool that gives better information to the team than they had before. So essentially each role does what it's supposed to do and brings their data on a weekly basis. Then the question becomes, okay, we've got all this data. What are we going to do with it? We're drowning in data, right? Industry 4.0 is absolutely drowning with data. We're drinking out of a 2.5-inch fire hose. We have to agree how we're going to make decisions with the data that we have. So we talk about the table and the funnel. Ultimately, we're talking economics. I love the definition that Thomas Sowell has given, that economics is the study of the use of scarce resources which have alternative uses. Fundamentally, the hours that we have, the people that we have, the dollars that we have are scarce resources, and our reliability success is going to be directly linked to how well we apply those resources, and that's why we use the example of a funnel. We put all the information on the table, we avoid the use of authority to make decisions, and we agree that those things whose condition tell us they need to be serviced are the ones that we work on first. And that new Bose stereo system that makes the ride to and from work a lot better, that's a nice to have. That has to go down at the bottom of the pie. And the team has the responsibility to raise their hand and say, boss, if you'll give me more dollars, more downtime, more people, I'll deliver to you a better result. And the same funnel happens at the plant level that happens at the individual team level of applying resources in different locations. So they bring their data on a weekly basis to that. And of course, 100% of the work that gets done in the weekly maintenance schedule is not simply responding to conditions, but other PMs, safety meetings, all the other things compete for that time and resources there that you're applying in the weekly maintenance schedule. So I want to take a second. You've got the understanding of the weekly meeting and the way the information flows together. I want to talk a little bit about two key roles within the organization, and particularly the two roles that have had the most benefit directly from the implementation of the KCF data. The first of those is the vibration technician, and when we embarked upon a pilot in 2021 to take a look at KCF, we started with the premise that we have got some of the smartest people in our plant walking around carrying a box all day long. putting on piece of equipment and spending a relatively minor part of their time. In fact, we saw in our reliability teams that we had many failures because the data had been collected, but the technicians had not had time to analyze the data. And in fact, one of our scorecard measurements was, did the Vibe Tech review the data and think about the data? So it's not just measuring wrench time. Vibration technician thinking time is absolutely as valuable as wrench time in that world. So that's why we started the KCF model. And we replaced this smart person, one of the smartest people in our plant, of walking around with a box in their hand to actually continuous review of data. And users of KCF have seen that benefit. What that did is it made better our vibration watch list. This is the tool that the vibration technicians use to communicate their information to their reliability team members. It's prioritized on those things that have to be taken care of immediately. We need to schedule an urgent shutdown to take care of that. Hopefully, most things fall into the second tier priority, which are those things that can be done on our next pit stop, on our next down day. And the green stuff is, well, that's something happening there. We don't know exactly what it is. We're paying attention. I'll tell you more about it next week, and we're going to watch it over time. And the value of that with KCF has basically been upskilling our plant. It's as if we have added multiple excellent vibration technicians to our organization because they're no longer wasting time walking around with a box in their hand. They're spending more time thinking about the troublesome assets amongst the hundreds and thousands of assets that we have, and they're spending time thinking about the most important pieces. So yes, we got the automation aspect completed by going with KCF, but interestingly enough, today, now that we've had it under our belt for the better part of a year and a half, some of the most excited and interested people are our operations folks. As we brought the data into the plant historians and put that data in front of operators, they began to realize that when we were taking weekly vibration data, we never saw the events that were damaging our equipment, the precursors to the defects that we ultimately have to take care of in the pit stops. And what we have found is that a grade change in our plant is just like me handing the keys of my brand new B&W sports car to my 17-year-old son and letting him drive 100 miles an hour through a rutted dirt road for an evening and do 2.5 years worth of wear and tear on my B&W in a matter of hours. That's exactly what we found by looking at our process on a more continuous basis. So we're continuing to learn and continuing to evolve. That data has been key as we've moved into adding the data to our work of our reliability engineers. You heard Jeremy talk about the value of this data, taking a look at root cause failure analysis. We have a structured DMAIC problem-solving methodology that our reliability engineers follow using fault tree analysis, and ultimately ended up, we talk about the condition monitoring is the net. We're down in shrimping country down there in Fernandina Beach, and we recognize that when we miss a big one, we've got a hole in our net. So these guys are key to weaving our net tighter so that we're not surprised. And at the end of the day, we have a management review process. And we want to make sure that each team is healthy and delivering the results. So we take a look at how are we doing this 12 months versus last 12 months. We don't want to look at this data on a weekly basis. You can see the upper right-hand corner of this graph shows the 12-month run rate. We want to see, is this area improving? What are those two big blips on the radar screen in January and March? What does the team know about that, and does it justify a redirection of resources to a different location? The net result of that is success from an OEE perspective. Our Jessup mill, which has the most KCF sensors installed, and an outstanding team led by Raymond LaCrosse and Jose Martinez, who are here with us today, lead an outstanding group of vibration technicians who fully embraced the data coming from the KCF system, going out and doing detailed analysis when they need to with their handheld box. And Jessup is delivering over 90% OEE. So, in a nutshell, our keys to success at RYAM is recognizing that we need to create engaged, empowered teams who are focused on no surprises. At the end of the day, it's not my birthday. I don't want to be surprised. I want to know what's going on with my equipment. And last, as we know here in an agricultural area, that things grow best where there's light, fertilizer, and water, and a little bit of weeding. So we provide this data at the management level to provide that nurturing and husbandry there necessary for success. That's it. Thank you so much for your time and attention.